Guys, welcome back. Hope you all are doing really well. Now, in this video, we will be checking out the lead code problem number 106, that is construct the binary tree from in-order and post-order traversal. Okay, so first we will be going on with the problem statement and then we will be checking out with the code part. Okay, so example 1 that is being given, you can see the tree is given. So basically this tree will not be given. This is just for the sake of our understanding part. Only the in order traversal and post order traversal will be given in the list. Okay, so in this, first you need to understand what is the in order traversal and post order traversal. Now if you don't actually know the in order and post order traversal, do check it out in my channel. I have already uploaded a detailed explanation about that, and then come to this video. You will be understanding more by that way. Okay, so in this video also I will be giving you a glimpse of what is in order and post order traversal and what is the important part just, but for this code and code part, and you have to go check it out that video. Okay, so in order, so coming to this example one is in order traversal and post order traversal will be given. Okay, so we will be making use of the how the in order and post order is being constructed. Okay, so I will be just explaining you with a rough work. Okay, so in order traversal, basically this is the same example that is given in the example one. Okay, so in order traversal is basically constructed with the left, root and right. Okay, so in order traversal, root will be in the middle and whatever comes to the left, like this part, will be the left part of the tree. Actually, the tree that will be constructed at the end, and whatever comes to this part, the nodes that you can see 15, 20 and 7, that will be coming to the right part of the tree. So this is actually the both part of the root, that is 3. Okay, and coming to the post order traversal, it's actually constructed with left, right and root. So the main part, that root will be coming at the end. This is the main understanding part of our question, that root will be coming at end. So we will be taking up the last element of this as a root node. This is the first step that we will be taking up, and we'll be proceeding with our next further steps of the solving this problem. Okay, so this the same way, first we will be taking up the root, that is we will be getting in the post order traversal end. So we'll be taking up 3, then we will be finding which index is there in the in order traversal, that comes the 3. Okay, third element comes. So here we can see this is the third 3 that's occurring. So this left part, that's 9, this will be coming to the left part, that you can see this is coming to the left part. Okay, now again we will be solving again this for the left part, and whatever comes to the right, it will be coming to the right part of the subtree. So with the help of recursion something, yeah, we will be using recursion in this, and we'll be solving this further, like 15, 20 and 7. Now again, if we'll come to the 15, 20 and 7, this is the sub array. You can see this is the sub array when we will be coming to this. So again we will be seeing like which element is there, which comes first in the post order traversal from the end. So 20 is coming first from the end, so that will be becoming the root. Okay, and whatever comes toward left of 20 will be the left part of the subtree, and whatever comes to the right end will be the right part of the subtree. So this 7 becomes the right end of this tree. So that way we will be constructing the tree. Okay, so output will be the normal tree traversal, and we will also be including the null. If the left child and right child of this any of the node is null, so we will be adding null in our output list. Okay, I hope you are getting it. The approach that I have explained, that will only will be using it in the code part. Okay, now what if our in order traversal and post order traversal is just given with single node -1, so that means we just have one node that's -1. Okay, so let's get started with the code part. I'll be using Java. Just understand the approach. You can code it in any language. Okay, so in this we have to be returning the tree node. So I will be using this tree in a separate function, and let me give the same name, I will give the same name. Okay, build tree, and I'll be passing this in order post order list that is given in order. Okay, and post order. Okay, and we'll also pass the size. Okay, let me just pass on the size of this in this column only. Okay, just side by side. Okay, and then not this will be becoming a really big name. So in start I will give in start. Okay, and okay, in start will be the 0 only. Okay, so in end I can give end post order 0, and I can give post end. Okay, post end. Okay, then this is the function call. Okay, so this is the function call, and whatever comes from here I will just return that thing. Okay, now let me just catch up the values. It will also be returning the tree node. Okay, so tree node will be returning, and we have to take up the same name as we have called. Okay, and here we will be adding the in order and int, and this I will be naming as int start. Okay, this is the starting index of in order array, not array, yeah, it's actually an array. Okay, and in end, it's actually stored in an array, single dimensional array, and this will be again the post order. Okay, this is again an array. Okay, post order. Okay, and this will be in post start. This is the starting index of the post array, and end index, so this will be post end. Okay, so now since we have created a user defined function, so we have to return some base condition, like if it's just one element, or if there is no element, then what it should return. So if my base condition will be like starting index is greater than the end index, that time it will be returning the base condition. Okay, so I'll be adding the base condition in start is greater than in end. Okay, or the same thing can occur with the post order array. Post start is greater than the post end, so at that time we will be returning the null value, like in the last node. So last node it will be returning, like we want the left and right child to be set as null, so we will be returning null over here. Okay, And let me proceed with the further things. Okay, now first, as I told, like in the post order traversal, we'll first extract the last element of this, as and that we will set that as the root element. Okay, so just extract the last element. So int root value. Okay, what is the root value of r that we will get in the last element of the post order? So post order array, that will be the post end we will get it, and we'll just make it as a root node. Okay, so creating a tree node and storing it in a root named node. Okay, new tree node, and we'll give this as a value, root value. So as we will be extracting this root, we'll just make it as a root of the tree. Okay, and then we will be going to the in order array, and we will be getting the what is the index of this root element that we have just came across. Okay, so for, okay, int, I should start with in order start. So in start, and it should go till in end. Okay, now I'm giving it as a less than and equal, because here I am okay, no, here I'm not passing -1. Okay, I assume that I'm passing this -1. Okay, so here I will just in dot length, yeah, I am doing a mistake. So in end, no, this is wrong. In order in order dot length -1, and this is also post order dot length -1. Okay, post order dot length -1. So here it will be catching up the whatever the size will be there, it will be catched up over here. Like in start will be taking up 0, and in end will be taking up in order dot length -1. So now it's perfect, and here I should be less than equal to in end, because I am passing the in order length -1. I'm already subtracting the extra counting. Okay, so here I'm taking equal, and here I will be incrementing my I value, and if any point, if my in order element I, it's equal to root value. Okay, if it's equal to the root value that we have extracted over here. Okay, so at that time we will store it in a root index. Okay, root index is equal to I, and we will break the loop, and we have to initialize what is root index. So int root index is equal to 0. Okay, so here we will be initializing, and once we get the root element, now as we got this 3, so again we can proceed with left and right in a recursive way. So for that we have to get how many elements are there toward the left and how many elements are there toward right. Okay, so for that I will be taking up int left size. Okay, left size, that will be equal to root index, whatever the index will be there, like 1. Here it is 1 minus int start. What is the start? 0. So 1 minus 0 is 1. So that means left size is 1. That's absolutely perfect and matching to our example. So here it will be the root index minus int start. So that is will be matching, and what we will be doing with right size is equal to, now right size will be in end minus root index. So end will be like 0 1 2 3 4, so it will be 4 minus 1. that will be 3. So 4 minus 1, 3. That's absolutely the size of my writer part, that's 3. Okay, so this will be in end minus root index. Okay, so that is the right size, and then we will recursively call the thing. Okay, root dot left one part and root dot right one part, and we will finally return the root element. Okay, so this is the overall what we will be doing over here, and now it is time to call it recursively. So we will be calling the same function build tree, and we'll be putting the values, just same thing will be here. Okay, same thing will be here. Okay, now okay, yeah, here we will be passing the in order array, and what will be the starting now what will be the starting of this in order that we will be passing in the left part. So what is this left part? Root index. It will be starting from in start and till root index minus 1. Okay, so here we will be passing, it will start from in start and it will go till root index minus 1. Okay, now coming to the post order traversal. From it should start from here, that is sure. Okay, so it should start from post start, but from where it should go till where? So we have the size of the post like 1 is the size. Like we also know actually one element is there, but in this whole post order, how we'll come to know? So we have the size of the left part, so this one, so we will add it to the post start is 0 plus the left size we are getting 1, so we will add it and till there only we'll go. Okay, so here post order array, it should start from post start only, post start, and it should go from post start plus left size and minus 1, because it will it is starting from index 0, so it should when it comes to 1 it should terminate this condition. Okay, so minus 1. Okay, now coming to the right subtree. The right subtree will be starting from index plus 1 and will be going to the end of the in order array. So here we will be passing the in order, and it will be starting from root index plus 1. Okay, and it will go till end. Okay, then it will be the post order, and it should go till no, it should start from the post order. We know the number of element in the left subtree, that is in the left size. So we will be just from the post end we will be just subtracting this right size. Okay, so we will be on the starting of the subarray that is in the right part. So we'll be taking up the post end minus the right size. Okay, and we will be going till the post end minus 1. Okay, so I think we have finished with everything. So let's run this and check if there is any error. So yeah, I got a semicolon, I missed it. Okay, one more is there. What is it? Expected a semicolon, it's already there. build tree in order 0 length -1 post order dot length. Okay, post order dot length -1 size variable post order. Okay, post order where it's missing, post order. Okay, order. Where am I missing? 39 number in order. This will be post start. Okay, this R is missing over here. Yeah, it's running for two test cases. Let's check for all of the test cases. Now it's running for the space complexity and the time complexity. Okay, so yeah, got this thing. This code is running perfectly, so you can just try it. And if you have any other method to solve it in a better space and time complexity, do share it in the comment section, and meet you in the next video with a new set of problems. Till then, keep practicing.